Hi folks, this is related trigonometric graphs. Now there's four things that we're going to look at here that can change depending on what we do with the equation of a trigonometric graph. I'm going to show you it with y is equal to sin x. If you take different inputs and you put them in instead of x there, you'll get a graph that I'll show you in a minute. So if you put in the inputs pi over 2, pi, 3 pi over 2, 2 pi, and so on, and then the same with the negatives, negative pi over 2, and so on. If you put them in there for that input, for that x, you'll get a graph that will look something like this here. So and that's the way it'll look. So you'll get this up down kind of graph. So some things then that we need to understand about it are these things here. So the first thing is the range. So the range is the interval on the y-axis from the lowest to the highest. So that's quite easy to see. All that means is it's just the distance from the highest point to the lowest point. So you should be able to see there that it goes from 1 down to -1, and that's what the range is. So the highest thing is the 1 and the lowest thing is the -1. So if we were to get the range for that one, it would be 1 to -1, or I should probably put it in between there. The midline, that's just a horizontal line which lies halfway between the highest and lowest points. In this one here, our midline is going to be the x-axis. So that's what our midline is, because that goes exactly through the middle of the graph. That's what midline means. Amplitude, you can see on the picture here that amplitude is kind of how far up the curve goes. And the curve could go up further and down further like that, and it could go up further again and down further again, depending on the function of the graph. And that's another thing that changes. So it's from the midline to kind of how far the upper curve is, or how far the down curve is. The period, that's the shortest distance along the x-axis, which the graph repeats itself. You can see here that at that point there, from there the graph goes up and down and up, and it gets back to that point again, and then that is just going to be repeated after that. If you were to draw a line up between those two, that whole thing is just repeated again, then it's down, up, down again, and so on. So the period is just it's one kind of part of the graph that gets repeated and repeated and repeated again afterwards. Now the first thing I'm going to look at here is if we take that graph y is equal to sine x. If you think about it, if you put a number in front there, so if we do y is equal to 2 sine x, so if you think about it, when you put in a value there, for example, if you put in pi over 2 in instead of x into sin x, you'll get 1 as a result, so that would be 1 there. But if we get, that means that we would get a 1 there then, and then that would have to be multiplied by 2, so we'd actually get 2 in the end. And the same here then, so if we put y is equal to 3 sin x, so sin of, if we put in the pi over 2 there instead of the x, that will all give us 1 there, and then it gets multiplied by 3. So what you can see is that the amplitude of the graph actually increases when you put a number in front like that there. So if we put in y is equal to 7 sin x, well then that will make the amplitude get higher again. And here, so if I change the function around, so that there is the function y is equal to sin x. If I put in maybe a 2 in front of that, the amplitude gets higher of the graph. And then I'll go back, I'll put in a 3 now, and it gets higher again. So it's the amplitude that's getting higher each time, and then maybe a 5, and you'll see that it gets higher again. And you'll see then what's affected is the range is actually affected. When you put in a 5 there in front, now the graph goes between 5 and -5. That's what the range of the graph would be there. So that's how the amplitude gets changed. So depending on what number is in front of it, it's like the graph goes up more basically. So we'll change that back to y is equal to sin x. The next thing is the period of the graph, and that gets changed by, if we take y is equal to sin x again, if we take y is equal to sin of 2x, that's what changes the period of the graph. So if you think about it, if you were putting in, we'll just go pi over 2 again, that means that the angle is being multiplied by 2 first, and then it will actually give you what sin of pi is, and that's what the output would be there. And then if you're to go on again, so y is equal to sin 3 of x again, so that now you'd have y of sin 3 pi over 2. So you can put all these into the calculator and see what point they actually give you. But what actually happens on the graph, I'll show you here, is it kind of gets scrunched up, so the period will become less. So if I was to put in a 2 in there, now you've got more up and downs going on than you had before. And then if I was to put a 3 in, so the graph y is equal to sin 3x, it gets more scrunched up again. And then I just put in something big, so a 10 in, so you can see what happens there. Now if I was to go back and change the amplitude as well, and we already know from what I said that if I put maybe a 3 in front there, that will make the graph go up then. So we can see how the graph is starting to change depending on what, if we put a number in front of the sin, or if we put it into where the angle is. So if I put maybe something big in there again, a 10 outside, now you've got that going on. So, and then if I was to reduce this back down, maybe a 5. So now what should happen is the graph will be more spread out. Yeah, so slightly. And we'll reduce that back down. And we go back to our graph y is equal to sin x again. So that's two things that have changed so far. So now we know that if we put a number in front of the sin out here, then the amplitude will increase. The graph basically goes higher and lower. And if we put something in front of the angle in here, well, then it becomes more scrunched up. It becomes more together, so there's less kind of space in between the lines going up and down basically. Right, so there's one more thing that can happen to it then. So we'll go back to our graph, y is equal to sin x. So if I was to put a number out in front here, so maybe 2, and I add it on to the function. So what happens here then, y is equal to 2 plus sin x. So if you were to think, you were putting in your angle there into it, like that, and you were to get something out of it. So for example, when I put in pi over 2, like I said before, in there, we get 1, okay? We get 1 as a result. But if I was to add 2 onto that, then our output eventually would be 3. So our y value would be 3. So no matter what we put in, output will be increased by 2. That's outside. And then if I was to put something bigger in there, maybe 10 plus. So again, if I was to put pi over 2 into my function, that will give me 1, but then we'll have 10 plus 1, so my output would be 11. So our y value would go all the way up to 11. So it's like it pushes the graph up. So if we put a number in there, okay, so if we put a thing in there plus our function, it'll just move the whole graph up the y-axis. And if I was to put a negative number in there, it'll actually move it down below the x-axis. So I'll show you on this now. So if I was to do 2 plus sin x, what's going to happen is it's going to just move up. Everything will move up away from the x-axis. So it goes up there. And if I was to put in a 5, it'll move up further again. So notice again now the range is changing here. So that graph then would have the range of 6 to 4, because that's the highest point and the lowest point on the y-axis. And then I'll put in something bigger again, so 10, and it moves all the way up again. And then if I'm to put in a negative number, I'll just put in -2 there. Well, I'll put in -1 first, and it should move back down below the x-axis then. So our midline there will be below the x-axis then, so it's no longer the x-axis. Now if I was to put in -3, and there the graph moves down here. So you get the idea. So if I was to go and experiment with it then, so if I was to put in 3 plus sin x, so now I know the graph will move way up above the x-axis. Well, not way up, but it'll move up above the x-axis. If I'm to put maybe a 2 in here, so now I know that the amplitude will get higher. Okay, the distance between the highest and lowest point will be increased. And then if I was to put, maybe you just put a 3 in there as well, now I know the graph will be scrunched up more, so that the period of the graph will become less by 3. So this is what happens then. So it's like what we predicted. If we're to look at a few questions here then, so the first one, it's finding the amplitude and the period of each of the graphs. So the first one there's a number just in front of the sin, so that means it's going to change the amplitude. So the amplitude then is that number. It's going to be 3, because it's going to stretch up the graph up 3. The range would be between 3 and -3, and then the period won't change because there's no number in front of the angle. It's just sin x. Second one, the amplitude would be just 2 again. It won't, just because it's a minus won't change how it's still being multiplied by 2, so it'll still stretch up 2. Then period won't change again. It'll still be just 2 pi or 360 degrees. The third one then, y is equal to 4 sin 4x. Well, then there the amplitude will be 4, and if you do 360 or you do 2 pi divided by 4, well, it'll give you 90 degrees, or pi over 2. That would be the period there. If we take whatever number is beside the angle, so if we divide 360 by that, or if we divide 2 pi by that number, it'll tell us what the what the period is. Then next one, 1 over 4 cos 2x. So in that one, the amplitude will actually get smaller, so it'll only be a quarter of the size. So the range would be up to a quarter, and well, a quarter and minus a quarter. And then the period, if we do 360 divided by 2, gives us 180. So 180 is the period, degrees is the period, or pi is the period. Write down the period then of the following graphs in radians. This is question 2. So they want it in radians, so we should be looking at the 2 inside the angle here. And if we just do 2 pi divided by 2, it gives us pi. That would be what the period is there. The next one, the period, it would be, they want it in radians, it would be 2 pi over 3. That's what the period would be. Then the next one is the same, so 5 cos x over 4 is the same as 5 cos 1/4 x. And if we do 2 pi divided by 1 over 4, it will give us 8 pi, I think, there. The next one, if you do 2 pi divided by 6, it just gives us pi over 3. That would be the period there. And that's question 3 then. The range, well, because there's a 2 in front of the sin x, that means the amplitude is 2. So the range would be between 2 and minus 2. Next one, the range would be between 5 and minus 5. Then the range would be between 8 and minus 8. And then the last one, it would be between 6 and minus 6, because there's a 6 in front there. So remember then, the number in beside the angle, so the whatever x it is, that's what changes the period. Okay, and if you take 360, or if you take 2 pi and divide it by that number, it'll always tell you what the period is. The number just in front of the sin or the cos, that will change the amplitude. That changes how much up or down the graph goes by. And then if there's a number being added on or subtracted out in front, then that will just move the graph up or move the graph down, depending. So that's it. That's all for the video.